Okay, geometry fans, so today we're going to look at section 5-4, which is inequalities in one triangle and something called the triangle inequality theorem. And we're going to break these notes into several parts. Usually it's 2 parts for the notes. It's going to be longer than that because we have 2 main concepts that we need to talk about, and we're going to really concentrate on each one individually. So for the first one, we're going to look at inequalities in one triangle. And before we start this, let me give you your math joke of the day. The question is, how do you make 7 even? How do you make 7 even? And the answer is, you take off the S. E-V-E-N. Okay, so first thing we're going to do here is a little bit of an activity. We're going to use a protractor to draw a triangle. You can just use a straight edge like a ruler. Measure the 3 sides and angles, compare the angles with their opposite lengths. So the first thing we'll do, let's draw a triangle. We want this to be scalene. So we want this to be a scalene triangle. Okay, so there's that right there. Okay, there's that right there, and then I'll connect it. Hopefully this is going to be scalene. Alright, so we'll call this triangle A, B, C. Now we want to measure the side lengths. Okay, so I can use a ruler. My protractor has a ruler on it. I'm going to do this in centimeters because it'll be a little bit more accurate. So the length of CB is about 7.3, and again this is centimeters. And then the length of AB, so from A to B, is about 5.9. Well, actually, yeah, 5.9. And then the length of CA, or AC, is about, let's see, I would say 4.2 for that. Okay, so those are my sides right there. Now, let's also do the angle measures. I will start with angle C here. So I'm going to put the circle, or the little cross of the protractor on point C. And I'm going to line up this bottom segment with this horizontal strip right here, where that goes to 0. Now let's see, CA kind of goes up here. That looks like that's about, and again I'm going to approximate, it's about 55 degrees, maybe 56. Okay, now the reason I know that I'm using the smaller numbers and not the bigger numbers is because I'm starting with 0, and so 0, and then 10, 20, that's this set of numbers right here. So that's about 56 degrees. Okay, so I'll label that on the inside. Now for angle B, I'm going to also line this up, but notice that the bottom side here is now going to the left. Okay, now it's going to the left. So what's going to happen is that I'm starting at 0 again. So let me line that up better. There we go. Okay, so I'm starting at 0, but now 10, 20, 30, those are my top numbers. So I'm going to go all the way around here. Now if I extend this, that's probably about 37 degrees. So there's 37. Now the last one, I'm going to do A, and to do that, I'm actually going to turn it kind of sideways here. Now, if I take the 56 and the 37 and I add them up, that gives me 93. And if I subtract that from 180, that gives me 87 degrees. So I'm expecting to get an answer very, very close to 90. Maybe a little bit less. Not quite a right angle, but close. Alright, so let me line that up again. Okay, so from 0... Wow, that is real close. Actually, it does look like it's about 90, maybe 91. Okay, so I'll call that, what I'll do is I'll actually give the, assuming that these two are accurate, then that would be this would be 87. Okay, maybe I'm a little bit off with my other two, but that's okay. If you're a little bit off, that's fine. The goal is to have 3 different sides, and then you'll have 3 different angles. Okay, that's the important thing, is that we can compare these. Now, the way that we'll compare them, let's go from, we're going to write this from biggest to smallest. Biggest to smallest. We'll do this with the angles, and we'll do this with the sides. Now, you may also see this greatest to least. That means the same thing. You might see for the sides, you might see longest to shortest. So there's a lot of ways that this can go. Okay? So I'll just say biggest to smallest for here. Now, let's start with the angles. The biggest angle was angle A. So angle A. Then my middle angle was angle C. And then my smallest angle was angle B. Okay, and again, my numbers may be a little bit off, especially my degree measure, but it's pretty obvious that A is the biggest angle, that C is the middle, and that B is the smallest. Okay, now, in terms of these sides, the longest side, the biggest side is, I'll say BC. Okay, I could say CB, I'll just go BC. And I'm going to line it up like this. I'm going to write it just like I wrote my angles. My middle side was the 5.9, that's AB. And then my smallest side, my shortest side was AC. Okay, now, I want you to notice something here. There's a relationship between the biggest angle and the longest side. Notice that angle A and segment BC, they are opposite of each other. Angle A is opposite side BC. Notice that angle C, which was my middle angle, is opposite 5.9, which is my middle side. And notice that my smallest angle, which was B, the 37, is opposite the 4.2, which is segment AC. So notice that the biggest side is opposite the biggest angle. The middle side is opposite the middle angle. The shortest side is opposite the smallest angle. Now what we've done here is we've discovered a relationship. And this can go 2 ways. So we've got 2 things, 2 theorems that we're going to write down. So a theorem is just a rule that we can actually prove. Now we haven't really proven this, but what we've done is we've demonstrated that this is true. At least in this case. But actually it's going to be true in every case. So, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So if we have a triangle, and we'll call this thing ABC, if you know, and we'll say that segment AB is 10 and segment AC is 6. If this is true, okay, AB is longer than AC, then what we can say is that the opposite angle of the longer side, so opposite of the 10 was angle C, that has to be greater than opposite the shorter side AC, which was angle B. That's always true. If one side is longer than another, then its opposite angle is bigger. If one side is shorter, its opposite angle is smaller. Okay, that's always true in one triangle. Now, it also works, let's say we're comparing, instead of going from the side lengths to the angle measures, let's go the opposite way. So let's say that we know that, so here's our triangle again, there's ABC. Let's say this time we know that angle C is 80 degrees and angle B is 40 degrees. Now if that's the case, angle C is larger than angle B. That means that the opposite side, okay, you can use a different color if you want, the opposite side, which is AB, has to be greater than the opposite side of the 40, which is AC. And what this theorem says, if one angle of a triangle has a greater measure than another angle, so if 80 is bigger than 40, then the side opposite the greater angle is longer than the side opposite the lesser angle. So basically what we just drew here, the bigger angle is opposite the bigger side. The smaller angle is opposite the smaller side. This is always true. Okay, so let's do some examples here, and we'll start with example number 1. List the angles least to greatest. Now least, this is real important how you read this. Least is the smallest, greatest is the biggest. So we've got 3, we've got blank, we don't know that one yet, and we've got 5. Now I'm just going to tell you that the answer here for this is 4. We haven't really talked much about Pythagorean theorem. We could have solved this if I said that that was x. I could have done 3 squared plus x squared equals 5 squared. And that's 9 plus x squared equals 25. And then we subtract 9, and we get x squared is 16. And then we square root it to get x is 4. Now again, we haven't looked a whole lot at that, so don't worry about that. If that didn't make much sense, just trust me when I say this is 4. List the angles least to greatest. Now they don't tell us angle measure, they tell us side length. But we can compare the angles because we know that the smallest angle is opposite the smallest side. Now we're starting with least, which is smallest. The smallest side is 3. That's AB. That's opposite. What's the other letter? This is vertex A, vertex B. There's my segment. The opposite angle is C. So angle C is the smallest. So I put that first. Then we've got the middle side is 4. Now that's BC. That would be opposite angle A. So angle A must be the middle angle. And then the longest side is 5. So that's got to be opposite the biggest angle, which is angle B. So angle C, angle A, angle B. That is the order, least to greatest, of your angle measures. And that is the end of part 1.